Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Welcome to a brand new episode of the Clear to Send podcast. This is Francois, your host, and this week we'll be talking about AP on a stick site surveys. So I'm recording today alone. Roel is a little sick and he's been hit by allergies, so I'm here today to talk about AP on a stick. I'm actually remote. I'm in a hotel in the UK, so I found a quiet room to record this episode, and I wanted to talk a little bit about AP on a stick and how we use it today in our Wi-Fi work, because historically AP on a stick was pretty much the way to find out where to place the access point back in the days when we didn't have the fancy software we have today to predict where the signal will go. So we would go on site and then define exactly where our access points would go. But we still, even if now we do have the software to predict where the signal will go, we still use AP on a stick site surveys. So I want to talk a little bit about it and see, when do we use it and when does it make sense to use them. But first, let's talk about, let's define what AP on a stick is, right? So the AP on a stick, you pretty much take the AP that you want to deploy, you go on site with it, and then you install it somewhere where you think would make sense according to your design. You put it on top of a tripod, on top of a stick. You turn it on, and then you measure the signal coming out of this AP, and you try to assess the type of Wi-Fi cell you will have and how the signal will propagate in the real environment. And based on that, you can make decisions. You can define AP locations. You can change or adjust the type of antenna you're using. You can adjust your predictive model, your predictive design, and you can pretty much refine the work you've been doing. The advantage of an AP on a stick measurement is that it takes into consideration all of the behavior of an RF wave, right? So it will pretty much measure the real RF propagation in your space, taking into account the free space path loss, taking into account the attenuation, the diffraction, the refraction. So you get all of that, and as a result of the AP on a stick, you'll get a pretty good idea of how the signal will propagate in your space. So disadvantage of doing AP on a stick measurements is that it takes a lot of time, and also it takes a lot of material to be able to achieve, right? You have to go on site with all of your stuff. We'll talk a little bit about what type of things you'll need to do an AP on a stick. And then you have to spend the time to do, set it up, measure, move to the new location, set it up again, measure, rinse and repeat. And depending on, the area you need to cover, it's going to take a little while. Okay, so like I said, as an introduction, historically, we've been using AP on a stick site survey to pretty much design our Wi-Fi network. So you would go on site with the AP you wanted to deploy. You would find the first location based on the corner of the office of the space you want to cover. You place the first AP, you measure signal, and then based on the first measurement, based on the first Wi-Fi cell, you would place the second AP, and then rinse and repeat until you pretty much cover the full floor. And some people still do it this way in some environments. Some countries, I know each countries have their their way of doing things. And so the advantage, like I said, it's you're measuring how the RF will behave in the end environment, right? But it takes a lot of time. Nowadays we have tools, software, site service softwares, just like Ekahau and the likes, that help us to pretty much model the environment and then see how the Wi-Fi signal will propagate throughout that environment. So we don't necessarily need to go on site and measure every AP locations. We can pretty much use those software to model it for us and get a pretty good idea of how the Wi-Fi will work in the space. So the way we do it today is pretty much we can go on site. That's the best way of doing it. Go on site. The first time to just talk to the customer, do a walkthrough, and get a sense of what the environments look like. Get a sense of different ceiling heights, type of walls. If you can take some measurements of wall attenuation measurements at that point, that would be perfect, ideal to refine your model later on. And then you get to, assess, be in the space, take pictures and see how the environment will look like. You can also study your AP mounting locations, options, and you can refine any limitation that the customer might have. Sometimes the customer will tell you, I don't want the AP to be visible. Sometimes they'll tell you, I don't want to install the AP in certain locations. So you can pretty much take all of that information, take all of these measurements that you do on site the first time to later on do your model. And then after that, you start your predictive model, predictive design in Ekahau or the likes. And then you draw the wall yourself. You set up the attention of those walls based on your measurements, the one you did on site. And then once you're done modeling your space, you can pretty much drop simulated APs based on the one you want to use for your design, obviously, and then see how the signal will propagate in the space in your model, right? And so you pretty much do the Wi-Fi design on paper, so to speak. And in order for those predictions to be accurate, you just need to make sure you do your homework and then you import the proper information, right? You need to make sure that the floor plan is up to date. You need to make sure that when you did the wall attenuation measurements, you are precise, and you incorporate that into your design. It's garbage in, garbage out type of things here. So you just need to make sure you do your homework if you want the model to be precise. So the advantage of doing it this way, using the predictive model, is that it's way faster to perform, right? And because it's faster, it's also cheaper, right, for the customer. So it's a big plus. Disadvantage is that it doesn't it's not as accurate as the AP on the stick measurements, because most of the times it only takes into account the attenuation that the space is bringing, right? So if you want the true RF behaviors, you really have to go on site and measure it. The model will get pretty close to it, but it will not be 100% the real RF will propagate in the space. Okay, so why do we still use AP on the stick today then, right? If we can just do our homework, import the good data, use the software to predict how the signal will go, propagate in our space, and then we're done. Why do we still use AP on the stick today? And the big reason one is because in some environment and some cases, the predictive design will not be accurate enough for us to be confident in the design, right? So in these cases, what we'll do is we'll start by doing a predictive design, and then based on the predictive design, we'll select a few AP locations that we want to test on site, right? And we could have multiple reasons for that. We could have been using directional antennas. We want to be able to validate a different type of antenna, different beam width. We're not too sure, different antenna height, different antenna inclination angles. And we want to be sure that it will be good on in the real environment. So we go on site and take some of those AP on a stick measurements. And sometimes when we do the predictive design as well, we're not 100% sure of some areas, or we want to make sure that Wi-Fi will be spot on in critical areas that the customer has defined. So we'll go on site and validate those areas, make sure it works. And then depending on the environment, sometimes it's hard to model. Stadiums have been notorious to be hard to model because of the inclinations of the floors, different design scenarios where putting access points under the seat versus putting the access point overhead. Some stadiums have both at the same time, so it gets pretty challenging to actually do the predictive model in those cases. So you want to go on site and measure it and test it. So depending on your environment and on the cases, you will want to do some of the measurements. In my case, when I work on designs, I always try to do AP on a stick when I'm using directional antenna, because it's easy to make a mistake with a directional antenna, especially in the models. If you change the orientation, you don't really notice, you make a mistake, then you apply it in your space. It's the antenna and the AP is in the middle of your walls, your attenuation areas. You don't necessarily notice you made an issue, and plus, I always want to be confident that the external antenna I'm using will meet my needs. And then if I need to adjust it, if I need to test a couple different antennas with different beam width, I have this flexibility. And at the end of the day, when I sign off on the design, and I'm sure that the antenna I chose was the best for whatever we wanted to achieve. And so the number of AP on the stick measurements that you will be doing will depend on the environment. Sometimes you won't have to do any, right? If I'm designing a simple office environment, I've been on site the first time, I've done my homework, imported everything in Ekahau, I'll be confident in my design. I won't need to do AP on the stick measurements. Sometimes you have to do 100% of AP on the stick measurements if you're designing for, complex industrial environment, outdoors, and very harsh environment. So it's going to depend on your needs. It's going to depend on your level of confidence as well, and it's going to depend on your past experience. And all of the goal pretty much of the AP on the stick measurements today is just to refine your predictive model, make it stronger, so you're sure that it will work well in production. So now, if you want to do an AP on the stick, what type of material will you require to perform an AP on the stick? So obviously you need the APs and the antennas that you will be using for the deployment. So most of the time you know exactly which AP or which APs you need to bring on site. Sometimes you have a couple of different models. If you need internal antennas, if you need external antennas, you'll be able to bring those models with you. Same with the antenna. Sometimes you have a good idea of which antenna you want. Sometimes you want to refine, and you bring a couple more just to make sure that you choose the right antenna for the job. You need to make sure that the AP you use are the one you'll deploy in the real world, obviously. Then you need a stick, right? AP on a stick without a stick would be silly. So a stick, most of the time it's a tripod or it's a pole. A tripod works pretty well. You have different height of tripods. Now on Amazon you find a whole bunch of different tripods for light features, video production, even photography. A few brands are notorious in that space. Newark, Manfrotto, and so on. So just search on Amazon and you'll find a whole bunch of different tripods at different price levels. And different heights as well. If you need to be able to travel with tripods, just make sure that, you can you find options for that, because if the tripod is big, it's not gonna be as convenient. I know a lot of people fly to go to site survey locations, so that's something to consider. If you want a tripod that go high enough. Poles, you can get painter poles to install an AP on. I've used it in the past. It's convenient if you don't have anything, or if you cannot travel with tripod, you can just stop at the local hardware store, pick up a painter pole, and use that for your survey. If you need to go very high, you might need to, you might need some help in warehouses. If I need to go high, I try to have a scissor lift. So you can either ask your customer or you can rent one. to be used for the time of the site survey. The beauty of the scissor lift is that you can operate it alone if you have your license. You can just pretty much place it wherever you want, and then step down, raise the platform, walk around, lower the platform, and then rinse and repeat, place it to the next AP location, and so on. What I do when I use the scissor lift or the skyjack, I like to use a painter pole because you can directly attach it to the side railing using zip ties or duct tape, and it works very well. The tripod is a little harder to install on the scissor lift. If you want to use directional antennas, sometimes it's nice to have a bracket that shows you the angle of orientation. So you can, let's say you're in a warehouse and you have a scissor lift, you can install it on the railing, and you can adjust the angle to refine exactly what you want. You can on top, so you have the AP, you have the stick, and how do you install the AP on top of the stick? You usually use the bracket. So some people make their own bracket. The one I like is called the Wi-Fi stand, and it pretty much mimics the T-rail railing of a drop-down ceiling. So it's compatible with pretty much any AP bracket that comes in the AP box. So you can install the AP directly on the Wi-Fi stand. And I like the Wi-Fi stand because the weight is centered on the center of gravity. So your pole will not tend to bend if it has some more weight to it. So anyone that tried to do AP on a stick with 3802s or with external antennas will understand what I'm saying here. But if you have the center of gravity of your APs and antennas centered on the stick, it's much easier to keep it stable and safe. I had a pole fall on me one day, and it's not a fun thing to happen. Thankfully, no one got hurt in the process, and the AP surprisingly was still working afterwards. But it's not something you're looking forward when you're doing AP on the stick work. So you need the AP, the stick, the stand to attach or the bracket to attach the AP to. Then you need to power the AP. So rather than running a long power extension cord, it's much easier to have a battery pack that will just power on your AP. Now we have a couple of options available to us that will just have a PoE plus port available to just power the AP straight out of the battery. So there's the Venvolt from Ventev, and there's the accelerator from Axeltex. Both have very good options. And they'll just power your AP for hours. I have the Venvolt with me, and I can go one day of survey powering my APs, even leaving the AP on during lunch, and I still have like 50% left at the end of the day. So those stuff are pretty amazing, and battery life is not your primary issue anymore when you do AP on a stick, which is very nice. And then those batteries also have an additional Ethernet ports. So if you want to connect to the AP, being able to SSH into the AP, reconfigure it while it's up in the air, you have that option. If you want to connect to a DHCP server or a WLAN PI to do some throughput testing, you have that option as well. It's very versatile, and it also has a USB port if you want to charge your phone or charge your laptop if your laptop allowed to be charged on USB-C. So battery, and then obviously you need to connect the battery to the AP. So you'll need a long Ethernet cable, right? If you're doing an AP on a stick in a retail place, let's say, and the ceiling is 20 feet high, you're gonna need to have a pretty long cable. I'm a big fan of the flat Ethernet cables for those type of work because they are very neat and you can keep them along your pole. It looks more professional, and plus it's easy to carry around, right? So you can same thing on Amazon. You can find those flat Ethernet cables at different length, and you can purchase the one that fits your needs. And then a couple of useful add-ons stuff you would need in order to do AP on a stick stuff I've used depending on the environment and depending on how long it lasts. But a good water bottle will be handy because you'll be walking a lot. Obviously, placing the AP, doing a measurements, walking a lot, and then moving the AP and then redoing the same process takes quite a lot of time, and you'll need to keep yourself hydrated. Then sometimes you need a flashlight, duct tapes. I just take it just in case. You might need something. Zip ties, marker, security boots, yellow vest, earplugs, safety glasses if you're in a more industrial environment. That's just a small list here. You'll find more. I included more, resources from other Wi-Fi engineers on AP on the stick. You might find other list, a more completed list. This is just the thing I try to keep with me when I do AP on the stick, just to be prepared and to be ready. Okay, so now how do you prepare the AP on the stick site survey? So first you need to configure the access points, right? Especially if you're dealing with access points that usually connect to controllers. When you do an AP on the stick, you don't have a controller, so you have to configure the access point in the most standalone mode. So each vendor have their own way of doing this. Cisco, now they use Mobility Express. They used to have a standalone image. Now it's ME, Mobility Express image. I wrote a blog on how to convert AP to Cisco Mobility Express and how to configure it as an AP on the stick. So you see the link in the show notes on the website clear2send.net/170. Aruba usually uses instant AP mode to do the AP on the stick. There's a nice blog from Scott Lester that I added to the show notes if you guys are interested in taking a look at that. Meraki has their own survey mode. I included the document as well. And each vendor, if you look online, you'll find their site survey or standalone mode that you could use to do the AP on the stick. What I like to do is I like to configure one SSID per frequency band. So I like to have my survey 2.4, my survey 5, and this allows me to first to better analyze or to analyze my results more easily if I want to do it a frequency band per frequency band. And this also allows me to follow my signal strength coming from my different SSIDs while I do my survey. So I make sure that I'm walking far enough to actually cross my Wi-Fi cell that I've defined with the signal strength threshold. So I do it that way, especially if you guys are using Ekahau. If you use Ekahau, you'll have a set of tiles at the top that defines your requirements, and if you click on those tiles, you can specify an SSID. And so you could specify your survey SSID 2.4, and then at the top now Ekahau will show you only the signal trends coming from that SSID, so you can make sure that you're walking far enough to cross both your 5 gigahertz threshold and your 2.4 gigahertz threshold. Then when it comes to transmit power and channels, I use the transmit power that I have defined in my design. So remember, the AP on the stick will come after your predictive design. So in your predictive design, you should have set transmit power. So I'll use the exact same one to do my AP on the stick measurement, so I could compare, the real life versus my model. When it comes to channel planning, I would, if you already have your channel planning, I'll use whatever you have in your design. If you rely on ORM to do the channel planning for you, what you could do if you want to test the worst case scenarios, you could use the highest channels per frequency band, because you know that according to the free space pass loss calculation, you have more attenuation if the frequency is higher. So for 2.4, you could configure your AP on the AP that you're using for your AP on the stick. You could configure your 2.4 radio on channel 11 or 13 if you're in Europe planning on using it, and then you could configure your channel, your 5 gig channel on channel 165 if you're planning on using it, or whichever highest channel you're planning on using. And before you do your AP on the stick, so apart from configuring the access points that you'll be using, or the access points with a S, you should also have your predictive model ready before going on site for the AP on the stick measurements as much as you can. And then so you can compare whichever results you get from the AP on the stick measurements, compare it to your model and adjust your model as you go. Okay, so once you have all of that ready, once you have the all the equipment with you, you go on site. How do you perform an AP on the stick site survey? So first, how do you choose which AP location to test? Right, so it could be because of it's a difficult environment, you're in a warehouse, or you have a lot of large machinery, large attenuation areas, and you're not too sure you want to test those environments. That could be one reason. Another reason would be, you have elements in the real life that you don't have in the floor plans that the customer gave you. So when you want to make sure what type of attenuation those elements will bring in your design, so you want to test these. If you want to use external antennas and you're not too sure, you want to validate if it's better to install it under the ceiling, on the wall, the orientation of the antenna, the beam width. So that could be another AP to select, another reason. And also APs are near important areas. So that's some of the reasons. You might have other reasons, but that's some of the reasons I could think about when I was preparing this podcast. Once you've defined exactly the APs, the AP locations you want to test, you go ahead, you set up your stick, the AP, you place the AP and the stick exactly how you would install it in the real life, right? So if the AP is supposed to be under the ceiling, you install it under the ceiling facing down. If for some reason you need to install it on the wall, make sure you place the AP on the wall as well. The Wi-Fi stand allows you to rotate the AP, so you can actually model an AP on the wall. And then once the AP is placed correctly, you turn it on, so you connect it to the battery, and you wait for the SSID to broadcast it. When it's ready, you can use your favorite survey software to measure the signal in passive mode, and you can actually only scan if you want to. Speed up the process. You can scan only the channels the AP is broadcasting. Okay, so typically one on the 2.4, one on the 5 gig band, and then you just go ahead and you measure signal around. You walk around the AP and you measure the signal propagation around the AP. All right, try to keep an eye on the signal strength you receive from the 2.4 gigahertz SSID. Make sure you walk past the threshold you've defined, right? So if you've defined minus 67 as your threshold, make sure you at least pass that threshold. I try to go up to minus 72, 75 if I can. It's very hard to go minus 80, minus 85 because you'll end up doing a lot of work, especially if you're in a very open environment. But if you really want to be able to measure the impact of if you want to be able to measure your Wi-Fi cell and the impact that the AP will have on your co-channel interference, you really have to go further away. But you'll see that in practice, it's pretty much not doable. It takes too much time. And then once you've done all your measurements, right, you go back to your access points, and before moving it to the next location, if you're using Ekahau, you have to freeze the AP in your survey to be able to decouple that measurements from the next measurements you'll do, because Ekahau by default merges all of your surveys. So if you don't want Ekahau to merge the different measurements and skew your data, since you're moving the AP, you have to freeze the AP in Ekahau before you move to the next location. And then you move to the next location, you place the AP, and then you rinse and repeat. You walk around, you measure the signal, make sure you go through past the threshold of your Wi-Fi cell, and then rinse and repeat for the other locations. Okay, try to document your work as well as you go. So what I like to do is take a picture of my my AP and the stick when it's in location, and then also try to take notes if I can. I add those notes and the picture in the site server software in APoS, so I can have it handy. And then if I'm working with someone, they can see those notes. Or if I'm doing if I'm doing some analysis of reporting later on, I can see those notes and I can reference them for the customer. So especially pictures are nice, because if your AP on a stick location happens to be exactly where you'll install it in the future, you can use that and provide it to the installer, so they have an idea of how to properly install the access point. And then it comes time to analyze the results, right? So when you're analyzing the result of your AP and stick measurements, you're trying to compare how the signal propagates in the real world versus what you had in your predictive model. And then if it doesn't match, you need to adjust your predictive model so your predictive model looks exactly like the real life, right? And so that could be an iterative process. And you might have to be, you might be doing this on site, right? Doing a couple of AP measurements and then analyzing it, fixing your model, going back, doing more AP on the stick measurements, and so on until you're happy with your overall design. Okay. Right. So that's pretty much the different things you need to keep in mind when you do AP on the stick site surveys. Just before I'll let you go, I had a little a last section on things you can actually do also while you're on site, while you're doing your AP on the stick measurements. You could also take that time to take that opportunity to do little things that will help you along the way. So here are a couple of things I like to do. So you can validate the final AP location. You can validate that the final AP location will work in your environment, right? So let's say you've defined something in your predictive model, you're going on site, and then at the location that you define in your model, you notice that you won't be able to install the AP over there because there's a big ventilation deck under the ceiling, or there's something that you didn't have on the floor plan that prevents you from installing the AP over there. So you can, when you do an AP on a stick, you can adjust those locations. You can move the AP, adjust your model, and make sure that every AP locations will actually work in the environment. I like to do that in warehouses specifically because you never know what you have under the ceiling. Sometimes you have big heating system, a ventilation deck. Sometimes you have a big crane to lift heavy material in industrial plants. And you don't always have those things on the floor plan. So you can check out those elements when you do your AP on a stick as well. Sometimes you can mark the AP location if you want to on site directly. So let's say you've done your AP on a stick, you've validated your design, you validated your AP location. So what you could do is you can take the opportunity to mark those location on site, right? A different way of marking things, but you could mark it on site so the installer doesn't have to relate on the floor plan only. They could just go on site and look up and see, oh, there's a pink sticker here, so I know I need to install the access point over there. You can take the opportunity to test different options, right? Test different heights for your APs, test different options, antenna options. Maybe an AP with a directional antenna under the ceiling is better than an AP with integrated antenna lower down, or maybe it's the other way around. So you could test that in your environment. You could also take a look and see how the users are using the Wi-Fi, right? Pay attention on where they use the Wi-Fi, how they do it, as a mobile, as a stationary. Sorry, that's the same thing. No. It's not the same thing. So are they moving around a lot? Are they staying still, being stationary? And where is the traffic? They have like a heavy, more busy route, and so you can study those places. Try to analyze where people gather, and try to see how if your design pretty much will cover those needs. And that's Leo's things you can do as you walk, right? As you walk, let's say you're doing a AP on a stick in a warehouse. As you walk through the aisles, you can try to observe what's going on, right? Where are the forklifts going? Where are the people scanning products and where is the stock being kept and all of that. Same thing in the office. You could, as you walk around, where are people gathering, right? What's the most busiest area? Are people on their phone a lot while they move around in the office, and little things like that you could pick up and try to make sure that your design will meet the end user needs, and then make sure that the end user has a proper experience over your new Wi-Fi design. All right, so that's pretty much it for today, and how we could use AP on the stick measurements today to help us complete and refine our predictive model. If you guys have different ways of doing things, if you do it a little bit differently, I know each country have their own way of doing things. So if you want to share and let us know how you guys are doing things and how AP on the stick measurements benefit your work, just feel free to leave us a comment or engage the conversation on Twitter at Clear2Send. And just as for more resources, we added a list of links that you could find in the show notes, clear2send.net/170. A couple of engineers talking about their AP on the stick site survey kit. So we have one from Lowland Wi-Fi, one from Gerpritzin, one from Nick Turner. And we also included a link to wifistand.com and hiverator.com. They both offer a complete AP on the stick kit if you guys are interested in taking a look at these. So anyway, that's been it for this week. Thank you again for listening. Thank you for reviewing us on iTunes. I've seen a lot of really nice and sweet reviews. And we're looking forward to hear from you on how you guys are using AP on the stick measurements in your Wi-Fi work. Thank you guys. I'll talk to you next week. Bye-bye.